Hello students, and welcome back to another geometry video. You know what to do. Pause the video, try this problem in your notes, and then unpause it to do it with me. Okay, the sum of the measures of the interior angles of a convex polygon is 1,440 degrees. So that means that n minus 2 times 180 degrees is equal to 1,440 degrees. If I want to classify the polygon by the number of sides, I need to solve for n. So, in order to do that, I need to divide both sides of this equation by 180 degrees. And 1,440 divided by 180 is, I get n minus 2 equals 8. Now, all I have to do is add 2 to both sides, and n equals 10. Because 8 plus 2 is 10. There we go. So this shape is an n-gon. This convex polygon is an n-gon. I dropped my pen. All right, that was a nice review from the last video. Let's go ahead and move on to what we have for today. Today we are still in section 7.1, and we are talking about interior angles today. So, the learning target is that you remember what interior angles of a polygon are. We looked at them in the last video. We're gonna dig deeper into them in this video. And our success criteria is that you can find interior angle measures of polygons. So, let's jump right into it. Remember that a polygon is a closed figure in a plane that is made up of 3 or more segments. So you can have a triangle or more sides, but no two-sided figures. Not in Euclidean geometry, at least. Oh, okay. So, anywho, closed figure made up of 3 or more line segments intersecting only at their endpoints. So, examples look like this. Let's talk about them some more. We have our interior angles versus exterior angles on this slide. So today we're going to continue talking about interior angles. In the next video, we're going to get into some exterior angle business. But for today, we're focusing on the angles inside of a polygon. In the next video, we'll focus on the angles outside of a polygon. Okay, a review from yesterday, because this is going to be important still for what we are doing today. The sum of the measures of the interior angles of a convex n-gon is n minus 2 times 180 degrees. We're going to need this for this video, for this lesson, and for the next lesson, so do not forget your Polygon interior angles theorem. All right, now this is new. This is new to today. This is a corollary. Now, a corollary means that it follows very closely from the theorem. So it's a corollary to the Polygon interior angles theorem, which means we get this result, we get this sentence right here from the Polygon interior angles theorem, but it's an interesting specific case, so we call it a corollary. But what it says is the sum of the measures of the interior angles of a quadrilateral is 360 degrees. Now, we could do that if we took n minus 2 times 180 degrees. A quadrilateral, quad means 4, lateral means sides. So a quadrilateral means n is equal to 4. And if we took 4 minus 2 times 180, we would get 2 times 180, which is 360. So we know this. We know this sentence because of the Polygon interior angles theorem. But quadrilaterals are very interesting shapes. We're going to spend a lot, and in fact 7.2 through 7.5, we're going to spend talking about different types of quadrilaterals and the special properties of them. So it's important that we know that any quadrilateral, any convex quadrilateral, has 360 degrees inside of it. Okay, let's go ahead and use this corollary in our third example, our first example of today, third example of section 7.1. We want to find the value of x in this diagram. So what is this angle right here? How many degrees is the bottom left angle of this quadrilateral? Now, because it has 4 sides, 1, 2, 3, 4, this is a quadrilateral. And hey, quadrilaterals have 360 degrees in them. So we know that if we add up all the degrees in this quadrilateral, we should get 360. So if we take x degrees plus 108 degrees plus 121 degrees plus 59 degrees, if I add all of these angles together, I need to get 360 degrees. Because the sum of the measures of the interior angles is 360 degrees. Sum of the measures of the interior angles of a quadrilateral. Remember, 360 is for quadrilaterals specifically. Okay, so let's do this. X plus 108 plus 121 plus 59. Let's combine our like terms. So 108 plus 121 plus 59 is 288. So we have x degrees plus 288 degrees equals 360 degrees. Now, I just need to subtract 288 degrees from both sides. And we get that x is equal to 72 degrees. Or x degrees is equal to 72 degrees. And there we go. Let's check and make sure that we were correct. I combined correct and right together. Whoops. So let's see. Yep, they added all of them together to equal 360. Combine like terms. Boom. X is 72. Nice work. Let's go ahead and move on to our next example for today. And this is actually going to be our last example for today. A home plate for a baseball field is shown. Explain. Oh, is the polygon regular? Explain your reasoning and find the measures of angle C and angle E. Okay, so this is what home plate looks like on a baseball field, right? And then you run off to first base. You come home from third base, all that jazz. So, first question, part A is asking, is the polygon regular? Explain your reasoning. Remember that a regular polygon means that all the sides are the same, it is equilateral, and all the angles are the same. It is equiangular. Now, it looks like this side, side AB, it looks like that is bigger than AE and BC. I'm not 100% certain, but it doesn't look equilateral. And if I look at the angles, I can see that angle A, B, and D are 90-degree angles. Angle E and angle C are definitely not right angles. Like, they don't have the red box on them, but also they are obviously bigger than 90 degrees. They are obtuse. They are obviously obtuse. So we can say, no, the polygon is not regular because it is not equiangular. Now we could say with a pretty good amount of confidence that it is also not equilateral. So we could say it's not equiangular and it's not equilateral. We could say that. The equilateral is less obvious. So my main reason is that it's not equiangular, and also it doesn't look equilateral. Okay, wonderful. So that's part A. Part B says to find the measures of angle C and angle E. Well, okay. I know that C and E are the same. Remember, that's what these semicircles right here mean. Because angle E and angle C both have one semicircle, it means that they're the same. So I don't know what angle C is. I want to find it though. And I know whatever angle C is, angle E is the same thing. So let's call them both X, since they're both the same, and I don't know what they are. Let's call them both X. Now all the rest of the angles we know are 90 degrees. We know because they have that red box in the corner that says it's a 90-degree angle. So, how many sides are in this shape? We have 1, 2, 3, 4, 5 sides to this shape. So, when I add up all of these, when I do x plus 90 plus 90 plus 90, what should that equal to? Not 180, this isn't a triangle. This also isn't a quadrilateral. There are 5 sides to this shape. So it's not 360. How many degrees are in a 5-sided shape? Why don't we find out? N minus 2 times 180, but now n is 5. I have a 5-sided shape. So this is separate from part A. But I have 3 times 180. I feel like I should be able to do that in my head. It is 540. So this shape has 540 degrees inside of it. So when I add all of the angles together, I take x plus 90 plus 90 plus 90. I should get 540 degrees. I will get 540 degrees because this is a 5-sided shape and I used my Polygon interior angles theorem. So, next, let's solve this equation. I'm going to combine my like terms. So I have x and x, 90, 90, 90. I'm going to put my x's together and my numbers together. So x plus x is 2x. And 90 plus 90 plus 90, I think that is 270 degrees. And that is equal to 540 degrees. Now I'm going to continue solving this equation. I need to subtract 270 from both sides. And I get that 2x is equal to 270. Yeah, 270 plus 270 is 540. Interesting. Okay. And now I'm going to divide both sides by 2, and I get that x is equal to 135 degrees. So, am I done yet? Not 100%, because it asked me to find the measures of angle C and angle E. Now, angle C and angle E are x number of degrees. We made them x degrees, and we found that x is 135 degrees. So, the measure of angle C is 135 degrees, and the measure of angle E is 135 degrees. Did you know that? Did you know that a home plate for baseball has 235 degree angles and 3 90-degree angles in it? Did you know that the sum of their angle measures was 540 degrees? Now you do. Now you do. Let's go ahead and check and make sure that we were correct. N minus 2, part A. Polygon is not equilateral or angular, so not regular. Sum of the measures of the interior angles is 540. X plus x equals 540. Measure of angle C equals the measure of angle E, which equals 135. We were right. Oh yeah. Okay, that's what I have for you today. So, what I would like you to do now is think back to our learning target and our success criteria. We wanted to remember what interior angles are. So, how do you feel about interior angles? And we wanted to be able to find the measures of interior angles. So, how do you feel about our learning target and our success criteria? Are you feeling a little confused on the examples that we did today? Are you like, okay, yeah, I think this makes sense. I'm not 100% confident, but it makes sense. Or are you like, woohoo, awesome, totally ready to do my homework and help my friends and classmates? Where are you at on this scale? Take the appropriate action. Here are some practice problems you can do to practice the skills that you have learned in this video. So we have problems like example 3, like example 4, and a little bit of a combination of like put example 3 and 4 together kinda in the middle here. So try these problems and see if you were right about, where you assessed yourself to be. Are you actually a 1? Are you actually a 3? Test yourself, see where you are. But of course, also do the homework your teacher assigns as well. And as usual, let's end our video with a launch, shall we? Today's launch comes from Josie Bissett. I hope I said that name right. And they say, dreams come a size too big so that we can grow into them. I love this saying, and I had never even heard of it actually until I went looking for a launch for this video. But I really, really like this saying. Dreams come a size too big. Do you ever feel like your dreams are too big? Like you'll never actually achieve them? Like you really want to, but it just seems so big, so impossible. Well, maybe that's how dreams are supposed to come. Maybe they're supposed to come a size too big so that you can grow into them. I have a dream right now of being able to like sew my own clothes one day. I want to make my own dresses. I want to make my own pants. I want to be able to take any fabric that I see and turn it into whatever I want. I don't know how to sew clothes right now. Right now I'm working on, blankets. I did a pillowcase yesterday for the first time. But I'm growing. I'm growing into being able to make clothes one day. So, I love that, dreams, maybe they're supposed to be too big so that we can grow. Life is all about growing, right? If we just stayed the same forever, I suppose you could, but to me, I think like the purpose of life is to continue growing, to continue becoming a better person, gaining new skills. So, it's possible. Maybe dreams are supposed to come a size too big to encourage us to grow and to keep growing so that we can reach those dreams. So if your dreams seem too big or too unattainable, hey, maybe that's just more room to grow. So that is my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day, and thanks for being here. Thanks for watching. Bye.